Welcome to today's live. And I'm sorry that I just started this live a bit later than what I intended, but hopefully it will still be alive with attending. Yeah, so obviously I think most of you who are here, hopefully, are people that obviously were told about this live. I'm just hoping all the others that actually were also told about it can join, especially those who are still writing. I know that most of you are still, some of you are still writing, you are still preparing, you are still, trying to do the most as far as making sure that, things are good. So guys, I just indicated that grade 8 and 9 learners that are still writing. Thank you for the heart me STXRZOV. Always showing love. I really appreciate that. Also those who are double tapping on the screen, I appreciate it as well, because that helps a lot insofar as just ensuring that the relevant people that need to be here are here. So basically what we are going to be doing today is just more and more geometry. Okay, it seems like there's a few people that are writing paper 2 both at grade 8 and grade 9 level. Now listen to me, grade 8 and 9, if you are here, you both are okay being here, because the paper 2 content that I'm going to be covering is applicable to you both. Now here's another thing. Grade 8s that are here, the grade 8 work is so similar to the grade 9 work. So when you go to grade 9 next year, please do not think that what you have learned in grade 8 is to be forgotten in the past because you are going to grade 9, because you are going to find that majority and all of the things that you are actually doing then are actually relevant. Okay. So I'm doing paper 2 today, all right? And that's final. So whether you are writing paper 1 on Friday or not, that's not relevant now. It just means that at another time, I'll be doing paper 1. But today, I'm doing paper 2. Now, I'm doing paper 2. I'll be doing paper 2 now because there are people that are writing paper 2 on Wednesday. And that's why those people, I've actually made it a point that I invite them to come here. And if you are here and you didn't know, well, you are here now. If you're writing paper 1 on Friday, then what's going to happen is that at another time, we will look at that, okay? Lebogang, for instance, is writing paper 2 tomorrow. You see? Exactly. Afternoon to you too, Ink FFX, if it is afternoon. If it is afternoon. All right, guys, so what I'm going to do is we are going to start it from geometry of straight lines. Geometry of what? Of straight lines. Geometry of straight lines. We're going to start smack bang there. We're going to spend some time and attention to that type of geometry of straight lines. My YouTube handle, guys, is MATHSISAGAME. You can find the link, it's in my bio, just so that I can get that out of the air now. The link is in my bio to my YouTube channel. You can actually check it out, it's there. I really appreciate the positive feedback that I've gotten from some people. Guys, I do know that the YouTube videos, they are not of the greatest quality. That I know. Like, you must know that I know that the YouTube videos are not of the greatest quality because they are actually extracted from the live sessions that I do here. So this here, you can see, is not quality in and of itself. So I download those videos as raw as they are. I extract them from this live lesson and I put them as they are. I don't do any edits, no nothing. So you get them as they are. So I really appreciate the good feedback and the positive feedback that I'm getting from some people. So thank you so much, especially because I think those people appreciate the content, the things that are covered. You know, if you are not taught at school, you can be rest assured that if you attend my live, you actually watch my videos of the recording of the live session, You will gain a lot. I can promise you that. Okay, so let's take it one step at a time, guys. There are things that we're going to have covered today, and I want us to answer the following questions because we're going to get geometry of straight lines up and rolling. So the very first question here is this one. Here we are. Question 1. Write down the following. The complement of 35 degrees. Guys, do we first understand the term, the word complement? Okay. Complement, supplement, complement. Do we all know what the word complement means? All right. So if I say, write down the following, the complement of 35 degrees, what do you guys have for me as an answer there in the comment section? What are you going to say? For 2 marks, for crying out loud. Check. 2 marks. What is the complement of 35 degrees? Grade 8 and 9. Yes, this is for both grade 8 and 9. So if you are in grade 8 and 9, you're in the right place. If you are in grade 10 and you just want to catch up on your basics, you are in the right place. If you are in grade 11, you want to catch up on your geometry basics, you are in the right place. If you are in grade 12, you're going to grade 12 next year, want to catch up on your basics, you are in the right place for your geometry. Okay? Yeah. Guys, the word complement comes from the word complementary, right? Complementary, what does that mean? The word complementary means angles that add up. Angles that add up to 90 degrees. I need you to understand these terms, guys. Complementary angles means angles, however many those angles are, that add up, okay, to 90 degrees. You need to understand the word complementary, right? So let's say I have 2 angles, 50 degrees and 40 degrees, all right? These 2 angles, when I add them together, they give me 90 degrees, all right? So we call these angles complementary angles. Why? Because they add up to 90 degrees. So 50 degrees is what we would call a complement of 40 degrees. Yes, indeed, if you are going to grade 10 next year, you can definitely watch. If you are done with your exams and it's all over and done, you are actually in the right place. So 50 degrees is the complement of 40. 40 degrees is the complement of 50. Why do we say 50 degrees is the complement of 40? Because these together, added together, give us 90 degrees. And these 2 angles, we call them complementary angles, right? So if I ask you what is the complement of 40 degrees, then you are right in saying the complement of 40 degrees, sir, is 50 degrees. Because what am I asking you? I am asking you what is that angle that I should add to 40 degrees in order to get what? 90 degrees. Okay, so I hope we are clear there in the concept of what a complement is. The complement is that angle that you add to another to get 90 degrees. Okay, so if we come back to the question here, and I say, write down the following, the complement of 35 degrees. Okay, Lekala lesedi is saying that the complement of 35 degrees is 55 degrees. Do we all agree then? Okay, Pamzamabona is saying as well, Ndando is saying the same. So I think we now understand the concept. Cheesecake, man, I love cheesecake, by the way. It's like such a beautiful thing. It's heavenly, that thing, cheesecake. Gianyame is saying 55 degrees. So we all understand then that the complement of 35 degrees is that angle we would add to 35, which will give us a sum of 90 degrees. So therefore, you guys are correct in the comment section by saying the complement of 35 is 55. Thank you very much. Guys, you need to internalize now that concept that you've just learned, that a complement is that angle you would add to another, the given angle, to get 90, all right? Because what are complementary angles? Angles that add up to 90 degrees. Let's move on to the next question. 1.1.2 says, the supplement, yes, Lebogang, I like that, 90 minus 35, I also love that. The supplement of x degrees, okay? the supplement of x degrees. For how many marks? For 2 marks. So once again, we are going to bring ourselves into that same situation of asking, what does this word supplement actually mean in mathematical terms when it comes to geometry? Okay, so I see there, let's say this is so supplementary equals 180 degrees, and I love that. Yes, let's say, thank you so much. So if we look at the second term that we have here, supplementary angles are angles, here look at this, angles that add up to 180 degrees. So you are 100% correct. So whilst complementary angles means angles that add up to 90, supplementary angles are angles that add up to 180 degrees, right? So now we are asking ourselves, so in just another example to actually utilize. So if, for example, I said, what is the supplement of 60 degrees? What is the supplement of 60 degrees? If I asked that question, what is the supplement of 60 degrees? What am I in essence asking? I'm asking you, what is that angle that you can add to 60 degrees that will give us 180? And so here you found me, Mikoso or Mikoko, and Ain't Garabo and Pams and Masejo are saying the answer would be 60 degrees. Starlight in the comment section is saying, sir, it would be 180 minus 60 degrees, which the answer that we get is 120 degrees. So you guys wrote 120 degrees, but the way in which you were able to get the answer is that you took your understanding of supplementary, which means angles that add up to 180, you subtracted the one angle that you are given so that you can find the angle that is the supplement of who? Of 60 degrees. So that is 120. So you guys are 100% correct. Okay. Now guys, I need you as grade 8 and 9 learners to internalize these two concepts and to not ever forget them. You cannot afford to one moment forget these two concepts: complementary angles that add up to 190 degrees and supplementary angles that add up to 180 degrees. Remember guys, this is just conceptual understanding of the two terms. We have not as of yet gone into questions that require us to find an unknown in a particular diagram. So there are no reasons that are needed for now. For now, we are trying to internalize what the word complementary means and what the word supplementary means so that we can be able to answer questions with regards to that. So the complement is the angle that we add to another to get 90. Whereas the supplement of another angle is that angle we would add to the given angle to get 180. So hopefully we get that. Now go back to the question. What is the supplement of x degrees? What is the supplement of x degrees? Okay, Cheesecake has indicated there in the comment section his cheesecake comment. Tandy is noticing that Melanie, a good friend of hers, is actually in the live session as well. Enkarabo is saying 90 degrees. Okay, what are the rest of us saying? What is the supplement of x degrees? Gienyame is saying 180. Okay, we have differing answers this time round. Enkarabo is saying 90. Gienyame is saying 180. Boshale is saying 180. Ambro, AMG is saying 180. Your favorite girl is saying 180. Starlight is saying 180. Pumza is saying 180. Mahlomuka is saying 180. Tasha is saying 180 minus x. Hey, you found me. Koso is saying 180. Mukhadi is saying 180. Mahlomuka is saying 180. Masejo is saying 180. Tasha is saying 179. Gotta Love Boga is saying 180. Ani is saying 180. King of Dark Road is saying mine. LDK, I don't know what LDK means, or is it I don't know? Oh, I don't know. IDK. Oh man, these 2K kids are saying all sorts of things. Tandy 180, Andy Lamado is saying 180, Sabella is saying 178. Say any number multiplied by 0 is 1. Oh my soul. Like I don't think 189 is correct. AKA Blessing saying 180. I mean 180 Starlight. Okay, let's hold it right there. So you will remember very well, guys, that when we wanted to find the complement, to find it, we first asked, what does the complement mean? That angle we would add to another to get 90 degrees. So the simple way to actually find the complement would be for us to take 90 minus 35. We get the answer. So we said that the complement of 35 degrees is 55 degrees. Now we are here now. What is the supplement of x degrees? So what would we do here in this case? We would take 180 degrees, right? And what would we do, guys? We would subtract this x that we are basically given, degrees, right? And guys, basically 180 minus x would be what we refer to as our supplement of who? Of x degrees. This is the answer. Okay, it's 180 minus x degrees. And so the person who was on the money with that answer was Tasha. Okay, Tasha said it. And Cheesecake was the very first person to say it from the get-go. So Tasha and Cheesecake saw the answer because the answer is 180 minus x. All right, that is the answer. So the supplement of x degrees is simply what? 180 minus x, right? Just like, what did we say? The complement of who? Of 35 degrees. Complement, we said 90 degrees minus 35, and what did we get? We got 55 degrees. Okay, when we were asking about the complement of 35 degrees, we said 90 minus 35, and what did you get as the answer? 55 degrees. When we were asked what is the supplement of x, we say 180, because we know supplementary angles are angles that add up to 180, so we say 180 minus the given angle. All right? Right? I hope that makes sense. So our answer for the supplement of x is simply 180 degrees minus x. Just as simple and as straightforward as it gets. Now, what we should realize is that when we take the answer we got and we simply go ahead and add it to that value that we were given at the beginning, it should give us that what? That 90 degrees that we're looking for. In the same way, if you take this x, you go ahead and you add it to 180 minus x, what you should get is that these two supplements should give you 180. What do you notice, guys? What's x and minus x? Those are like terms. So what's x minus x? That gives you 0. So what are you left with? 180 degrees. So that is why we say that the supplement of who? Of x degrees is actually equal to what? 180 minus x. This is the answer. 180 minus x degrees is the supplement of x degrees. Because when you add these two together, what do you get? 180. Just like the supplement of 35 degrees is what? 55 degrees. Because when you add what? When you add 55 and the 35, what do you get? You get that 90 degrees that you were actually intending to get. So I hope that makes sense. So guys, that was just a little bit of a sort of like introduction to what we wanted to get into. The meat of the business is this. Okay, the meat of the business is this. So guys, it's important to understand the difference between complementary and supplementary. It's just an important thing and an important concept to understand. Let's move on to this question now. Find the values of A to D in the sketches below, giving reasons. So what do we see here? We see a line and we see two other lines. All right, they all meet at this point. Okay, we call this point a vertex. What we want is the value of A. A together with this box, together with this 2a, have a relationship. What relationship exists between a 90 degrees and 2a? So that we can find the value of a, right? So what do you guys see? Okay, GY Inyame says angles on a straight line. Taski even goes on to say 2a plus 90 is equal to 180. Okay, all right. And then I see some people go on to even calculate and get the answer. All right, and they get the answer. All right, so people, very important. All right, I love what you guys are saying in the comment section, and I love it a lot. So yes, everybody in the comment section who said this here is a straight line, and that common vertex we have there enables us to see 3 independent angles. But if we actually move from this line to this point, we cover the angle A. From that line to that line, we cover the box, which means 90 degrees. This is a right angle, okay? 90 degrees, it means 90 degrees. From this line back to the straight line, we cover the 2a angle. So this common vertex that is shared with the 3 angles that are next to each other, we say that these 3 angles add up to 180 degrees. Why? Because these are angles on a straight line. So you guys are 100% correct in your conclusions and your deductions. So it would be very nice then, as many have indicated in the comment section, to say 2a plus 90 degrees plus who? Plus a is equal to what? 180 degrees. Okay, reason, as you have said, angles on a STR line. Okay, and our statement is 100% correct. Our reason must accompany our statement. If the statement is there alone without the reason, then in geometry, our working out is not complete. We must write the statement and indicate the reason for why we are saying that this statement is true. Okay? Do we all understand this? Does all 142 of you that are in the live right now understand that where this 2a plus 90 plus a is equal to 180 degrees comes from? And then lastly, why it is that we write the reason angles on a straight line. Okay? If any of you doesn't understand, this would be the best time to indicate to me and say, sir, I am completely lost with what you've just said to me. If we look at this diagram, there is a vertex. Guys, a vertex is a point where a couple of lines meet. So this line and that line and this line, they all meet at this point. This point is called a vertex. At the vertex, there are angles that are formed, 3 of which we know. This angle A, this angle which is a box which is 90, and that angle 2A which is an angle as well. So as a result, we can add these 3 angles and then conclude and say that because these angles share a common vertex and they are angles next to each other, or we say adjacent. The word adjacent means next to each other. They add up to 180. From here to there, from there to here, and from here to there, that completes a full protractor shape. From here, 0, all the way to there, 180. That is a full protractor. Okay? So we add these 3 angles together and we say we equal to 180 and we provide a reason. Angles on a straight line. Then we add the like terms that we see. So 2a is positive. A is positive. We add 2a and a together. Remember, when we add like terms, we keep the letter or the variable. Then we add the what? The coefficients. There's a 2 here before this a, and there's an invisible 1 before this a. So we say 2 plus 1. That gives us what? 3a. And then the 90 degrees is there as well, which is equal to 180. To solve an equation, as we have learned in equations, we then isolate the 3a on the left-hand side. We take the 90 degrees over to the right-hand side. When that happens, the plus 90, in actual fact, we talk about the additive inverse. Plus 90, if we want to get rid of plus 90, we subtract 90 on the left. But what we do on the left with the subtraction of 90, we do on the right with another subtraction of 90 so that the equation is balanced. But to shorten the process, we talk about transposing plus 90 to the other side, which basically says we have negative 90. Then 3a is isolated. 180 minus 90 is 90 degrees. Then the 3 and the a have a relationship of multiplication which combines 3 and a together. To get rid of the 3 that is multiplied with a, we divide by 3 using the multiplicative inverse. What we do on the left, we do where? On the right. We divide by 3 as well. So our a value is simply 30 degrees, grade 8s and 9s. So that is what the value of a is. Which means if the question had then asked me what is the size of each angle, it would be easy then for me to go and say this angle here is in actual fact 30 degrees. That angle there is 2 times the a value, which is 30. So 2 times 30 gives me 60. So that is 60 degrees, the actual size of the angle. Had I been asked to actually give the actual size, I was not asked that, but I'm just saying, guys, that is how we would find the actual size of the angle had we been given that question and we were being asked that. A is 30, which means yes, in the place of this a, we can write 30 degrees. In the place of this a, we multiply the 2 with a, which gives us 60. And yes, guys, what you notice, like Lekala Lesed is saying in the comment section, the 60 plus the 90 plus the 30 really agrees with the fact that those angles added together give us what? 180 degrees, which makes perfect sense. It is not senseless. It's filled with sense. So our a value is 100% correct, which means our calculations, they are magnifique, you know. So full marks here. 1 mark for statement, 1 mark for reason, 1 mark for simplification, and then the final mark for what? Our answer. That is 100% correct. Do you see, guys, how easy and straightforward it is to do these things? But please, guys, let's not forget the reason when we write statements and then the calculation with the answer. Let's move on to the next question. Grade 8 and 9, guys. This is grade 8 and 9. Okay. So if you are in grade 10, 11, and 12, you are in the right place as well because you need to get your basics nicely done. Let's look at the next question. We want B, we want C. Okay, you can see in the comment section, those people that are feeling the fire of the geometry, they know their stuff. You know, the geometry is popping out of their what is it? It's popping out of their ears and everywhere. So let's first acknowledge what's in the diagram. We see a line here, all right? Then we see what? An angle there, but it's on top of this line. This line is parallel. We see this angle, it's on top of this line. This line is parallel. And then we have B here, we have C there. And they're asking us, what is the value of B? and what is the value of C. So I can see in the comment section, many people who know their stuff are writing what they know. But I wonder about the people that don't know what they should know, if they know what they should be knowing, right? So just to sort of like help us recap a few things very quickly, just very quickly. We have what we call here a F shape, all right? We say that for the F shape, if there are lines that are parallel, guys, okay, if we have an F shape with lines that are parallel, we say that the top angle here, look at this, the top angle, this is one line, top angle, this is this line, top angle. We say top is equal to top. Top, we are equal. Top of this line, top of that line. The angles are equal. What do we call those angles? We call them corresponding angles. All right. Secondly, bottom of this line, bottom of the other line. We call those angles equal as well, and we call them corresponding angles. So what are we saying in summary here? The top angle is equal to the top angle for my F shape. But remember, guys, this line, okay, on the same side, we say top is equal to top, but it must be on the same side of the line. All right? So top is equal to top, bottom is equal to bottom. The reason we provide whenever we identify top being equal to top and bottom being equal to bottom is corresponding angles. And then very importantly, you must indicate whenever you write this reason, you must indicate as a matter of priority, you must indicate the lines that are parallel to accompany corresponding angles. If you don't write the lines that are parallel, I will go crazy, I will go crazy, I will go very crazy. If you don't write the lines that are parallel, you must write the lines that are parallel. You hear me? All right, so you must write the lines that are parallel, people. I beg you, I beg you, I beg you. Don't just write corresponding angles. I know the paper had enough. Do you know why? Do you know why it had enough? Because you guys don't write the line parallel. That's why it had enough. Okay, so please, guys, write the lines that are parallel. I beg you. What did I say? On top, the angles are equal. Bottom, the angles are equal. Top, bottom. On the same side, guys, of the transversal line. It must be on the same side. The angles are equal. All right? There is your reason. Mr. F shape. Let's move. Then we have, before we move to U, let's go to N or Z. This one I call N or Z. N, okay, or Z. The Z that is funny looking and the Z that is pretty looking. You know, the Z that is kind of like deformed, the deformed Z. I want you to take note of the position of the angles that we are saying are equal here. You see where these angles are situated that we say are equal. This angle equal to that angle. The lines must be parallel in order for them to be equal. That angle is equal to that one. The lines must be parallel. That angle is equal to that one. The lines must be parallel. What do we call those angles, guys? We call them alternate angles. ALT angles. semicolon. You must indicate the lines that are parallel. You must indicate the lines that are parallel as well. Parallel as well. You must indicate the lines that are parallel whenever you use alternate angles. Please, guys, indicate the lines that are parallel. I know I'm going crazy with the lines that are parallel because I tell you what, learners don't write lines that are parallel when they write these reasons. They just write alternate angles and then they think, voila, I have entered into the zone of full marks, and then they realize, no, you have not entered the zone of full marks because you did not indicate the lines that are parallel. Please, my children, I beg you, my children, write the lines that are parallel, and I'll be happy. You will be happy. We will all be happy. Yes, it's important to that point, I'm telling you. Write the lines that are parallel, my dearest children. Alt angles, semicolon. You indicate the lines that are parallel. So if they have the, let's say, AB, and then they have CD, after that semicolon, you write AB parallel to CD. I am just writing parallel lines here, guys, so that you understand that you must indicate, after you write alt angles, indicate the lines that are parallel. Okay, so what do we call that? Alternate angles. Alternate angles. But we use ALT for short and the symbol for angles, and then we indicate the lines that are parallel. That angle is equal to that angle. That angle is equal to that angle. Let's move on to the very last one. The U shape, all right? That is called co-interior angles. Those who have joined my live will know that when I refer to these angles, I refer to them as the armpits, the armpit angles. Imagine these were your two arms. They are stretched in front of you, right? What do you have there? You have the armpits where it stings. It stings very bad here in this place. This place, here and here, it stings very bad. You must put the roll on there for things to be better. So you add roll on. What do? You add roll on here. And when you add roll on, it betters the situation. So that's why I say here we are adding the two angles together. Okay? We add the two angles together. They are supposed, those angles, to give us 180. These angles are not equal, right? Remember, guys, armpits, we add roll on. So it means angles, we add them together. Are we together? We add the angles together. Just like we add roll on, we add deodorant, we add the angles together so that we understand co-interior angles. Please, guys, whenever you write co-interior angles, you must indicate the lines that are parallel. You must indicate the lines that are parallel. So we say that angle plus that angle is equal to 180 degrees. Reason, co-interior angles. You indicate the lines that are parallel. Co-interior angles. Ain't Karabo is saying he'll bring deodorant into the exam room just for that one. Go ahead, girl. Go ahead. Go ahead. Go ahead. Please, guys, we write co-interior angles. We don't write co-interior angles sub. No. We write co-interior angles, then we indicate the parallel lines. Yes, the angles themselves add up to 180, meaning they are supplementary. But when you write your reason, co-int angles, semicolon, you indicate the lines that are parallel. Nothing more, nothing else. Then, guys, there is this guy, there is this guy. Yes, you must indicate the lines that are parallel. Okay, it's co-int angles. You indicate the lines that are parallel. Please, guys, please don't write co-int angles sub as your reason. That is an incorrect reason. It's wrong. It's a wrong reason. Co-interior angle sub is used in another scenario. If you want to prove that lines are parallel, your reasons for proving that those lines are parallel will include the reason co-interior angle sub. If you can find angles that add up to 180 that are in the U shape, then basically we say that the lines are parallel, and after we indicate those lines are parallel, we use co-int angle sub. The co-int angle sub, the alt angles equal, and corresponding angles equal is reasons used only when you are proving that lines are parallel. When you need to prove that the lines are parallel, you use those reasons. Not for this situation. Okay? Yeah, don't make me guys bring out, you see. So anyways, then we have x. Okay, x has nothing to do with parallel lines. Okay, I usually call these the bagajuju. You know how Orlando Pirates fans, they have that symbol that they basically make whenever they are supporting their beautiful team. I call this X the bagajuju X. All right, that thing that they do with their hands, that's that crazy thing that they do with their hands. I don't know even if it's Guy Fawkes symbols or Halloween things that they do there. Even their attire there is Halloween stuff. Anyways, we are not there. The skeleton people. We say the bagajuju X, that angle B1, angle B1 is equal to angle B2. Yes, I'm a tambo, guys. Angle B1 is equal to angle B2. Reason. What do we mean? What reason do we use for that? Vert op angles equal. Yes, bagajuju style, guys. Angle B1 is equal to angle B2. We say these are vertically opposite angles. Angle EBD, this angle as well, is equal to angle ABC, this angle as well. So this angle and that angle are vertically opposite angles. That angle and that angle are vertically opposite angles. And we say vertically opposite angles are what? Are equal. Angle B1 is equal to angle B2. That's the reason we would use. There are no parallel lines because we are not talking about them in the context of parallel lines. We just say vert op angles. Okay? Yeah. All right. Guys, I think that about, sums it up a bit. Now we are back here. Knowing what we know now, we should all be in the position of telling me what angle B is. What is B? What is the size of B? And give me the reason that is the one that will make me smile, not the one that will make me sad. I need the reasons that will make me smile, not the ones that make me sad. So yes, B is 65. We can all agree. Why? We can see the parallel line. We can see the parallel line. Why do we know the line is parallel? We see the arrow. We see the arrow. So that means top is equal to top. What is that, guys? What is the top that is equal to the top? Yes, it's corresponding angles. But what do we need to make sure we don't forget as we write corresponding angles? Because I'm going to go crazy, guys, if you don't write. If you don't write that thing after corresponding angles, I'm going to go crazy. I'm gonna lose my mind. I'm gonna lose my mind. Okay, please, Dando. Yes, Ambro AMG. Yes, hey, you found me, Coco. Corresponding angles, parallel lines. You must write the lines that are parallel. Now, in most of your diagrams, you have the letters A and B may be there. Then you have D and C there. So when you have those letters to indicate the lines that are parallel, you would actually write B is equal to 65 degrees, corresponding angles, and then you would write AB parallel to CD. Okay. Does that make sense? Hey, Ink FFX, I think you are making a very good point. I think all of you in this live session, you owe me your reports at the end of the year. Because if I have affected or influenced the teaching of your thingamabob, writing of your exams, I need to see your report indeed, so that I can see if these things had an impact or not, or you are just sitting here smiling at the screen and not applying anything that I was teaching you. Okay, B is 65 degrees. We get it, guys. Reason? Simple. B is equal to 65 degrees. We just write corresp angles. And then since we don't have, we indicate parallel lines. We indicate that because we understand that those angles, the only way that those angles would be equal is because the lines are parallel. Then what I would do, guys, typically, I would take my pencil. After writing that answer, I would go and write 65 degrees in the place of B so that I update. What do we do when our phone is saying in need of an update? We update it. Why? Because when you update our phone, new features come into play, and then we can use our phone a bit more effectively because those features, they help us to be able to use our phone better. So I update 65, I write there. Then I see that 65 and I look, oh, 65 is a relationship with C. What is the relationship of this 65 that I have there, all right, with C? Narcissistic, thank you so much. C is equal to 65 degrees. Incarabo. C is equal to B indeed. C is equal to B, which is 65 degrees. What's the reason? That op angles equal. You guys are 100% correct. C is equal to B, which is 65 degrees. What's the reason? I know the reason. I am a master. It's the Bagajuju, guys. It is the Bagajuju. The Bagajuju angles have come into play. Vert op angles equal. That is the reason. Okay. So the Bagajuju, you can see it's that pirates thing there. It's coming into play, that thing. You see? Okay, let's move on to the next diagram. Guys, it's simple, isn't it? Okay, can I just get anyone who doesn't understand, before I move on to this guy, anyone who doesn't understand anything that we've done at the top here, you are lost. I don't know. I say I don't understand. Spiral is saying I don't understand. FF is saying I don't understand. Me. Spiral, what don't you understand now? You guys, yeah, you are killing me now. We get. KB is saying we get. I understand. Starlight is saying I understand. But it seems like Mr. Who's this? Spiral must have joined late. That's why he's saying I don't understand. Spiral, you joined 2 minutes ago, right? Okay, let's do this. Okay, I do believe there are people that are spamming. Let's do this quickly. Ink FFX, you're gonna help me out with that. You are now my moderator, Mr. Ink. Okay, just help me out there in that. Okay. All right, guys. I'm just asking at this part. Okay. Anyone who doesn't understand, remember the first thing we did here was that we said B is equal to 55 degrees. Why did we say B is 55 degrees? We go back to what I had explained earlier on. I said that for F shape, okay, top angles are equal. The lines are parallel. We are on the same side of the transversal line. The top angle is equal to the top angle. I said top is equal to top. Then I said bottom angle is equal to bottom angle. All right. Bottom is equal to bottom. That is corresponding angles. When we write the reason, we must include the lines that are parallel. That is our F shape for corresponding. Then Z shape, N shape, or the funny Z. If the lines are parallel, we say the position of these angles are alternate, but we say the angles are equal. We are saying they are equal. Why? Because the lines are parallel. So we call these alternate angles because of their position. But we say the angles, that angle and that angle, are actually equal. Why? Because the lines are parallel. So in our reason, we must include the lines that are parallel. Then lastly, the U shape, co-interior. the armpit angles. They add up to 180 degrees, these angles. We say those are co-interior angles. Why? Because the lines are parallel, the U shape. That is why, for instance, here, what did we say? Yes, go ahead, Dando. If you are writing NS, please go and study NS. Don't stay here. You can always watch this on YouTube at your own time, even tomorrow after you write NS, because I won't be live immediately tomorrow. Maybe when you come back from the NS paper, you jump on the YouTube and you can watch this thing. I'll be going on with this thing up until 12 p.m., just so people know. And it will be a very long live video. You can watch it at your own time later on. B is equal to 65 degrees, guys. Why did we say B is 65? On top, on the parallel lines. That's the F shape. Top is equal to top, so that is 65 degrees. Corresponding angles is the reason. We don't forget the lines that are parallel as part of our reason. We update. This is 65. Then we say C is equal to B, which is also equal to what? 65 degrees. Why? Vertically opposite angles are equal. We are done. Okay. So that is just a quick explanation of that one. Now let's move on to this one. We want D. Okay. We want D. Remember, my YouTube channel, link is in my bio, guys. Link is in my bio. Okay. Good night, Dando. Let's make our parents proud indeed. Good luck to you all. Good luck to you too, Dando. Thank you so much. Okay. I got an 85%. Guys, you see, I love these things. I love it when people just come here and they pin and tell me these things. I got an 85% on maths paper too. Thanks to you. I'm happy for you. I'm happy for you, my dear beloved, amazing person who just got 85%. Not because of me. I am not to blame for your marks, Tyrese. I hope you understand that, and I say this to my learners all the time. I am not to blame for your marks. You are the one to blame for your marks, Tyrese. It means that when you came onto my live sessions, you did not take my live sessions for granted, and therefore you utilized the information for your own benefit, for your own revision, and then it benefited you. So I'm proud of you. Good job. Beautiful stuff. 85% for maths is beautiful. It's a beautiful distinction. So it means next year we are definitely flying in the 90s, 95, 100. The sky's the limit. You know what I say. Okay. Thank you so much. I see in the comment section, many of you have commented about the next question, aka blessing. I see you there. You said AD plus D is equal to 180. Blessing. You are truly a blessing. Blessing, why did you say 80 plus D is equal to 180? You said because of co-interior angles. Blessing saw the parallel lines, and on top of that, he's seeing the U shape. You see the U shape? There is the U shape. These two angles, that angle. Starlight, you can go to my YouTube channel. I did perimeter and area during the weekend. I have a video that I uploaded. It's one of the most recent videos I uploaded. You can go watch that video. I actually started that specific video, started out by explaining area and perimeter for your square, rectangle, trapezium, and all these shapes. And then I moved on to surface area and volume. You can go watch that video. It's very long. It's 3 hours and so minutes, 3 hours and something. So if you feel that you are good with the geometry, please go there. Rather, go watch my most recent uploaded video on grade 8 and 9 maths paper 2. I specifically wrote in the title area and perimeter. Because that video is definitely going to be worth your time. Go and watch it. If you feel like you have a problem with area and perimeter, go watch that video now. You can leave the live session. Leave this live session, because when you are good with geometry, you are fine with geometry. All you need is to just hash up on the area and perimeter. Go check that out. Okay, it's a non-GEC. Okay, so U shape. So these two angles together make up this entire armpit where it stinks. And this angle, 80 degrees, makes up this entire armpit where it stinks. These two angles, that's where we need to put the roll on, guys. We need to put the roll on here, and we need to put the roll on there. Then what do? We add these two angles together. That's basically what we do. D plus 80 degrees, as you said in the comment section, should give us what? 180 degrees. What's the reason? co-interior angles. Then we indicate the lines that are parallel. Please, guys, do take your diagrams, move them around if you have to. Move them around. Move that diagram around until you can see what you need to see. You see what I see? You see what I mean, guys? No, I mean, move it around, guys. Move it around. Move it around. Show some energy. Show some passion. Show some fire. Move it around if you have to. And then you can see that it's there. It's staring right at you. The you is staring right at you. Okay? So yes, D plus D plus 80, 180 degrees. Look at what Grace has said there. I don't even have to write it down, this thing. Okay? The pin comment, Grace. Okay? Okay, you can see what Grace said there. 80 plus D plus D is equal to 180. But remember, Grace, don't write co-int angles alone. You must indicate the lines that are parallel. So your reason is incomplete. Mr. F, Mrs. F, or Mr. F, also your reason is incomplete. You guys are writing co-interior angles. The lines that are parallel are not included. F is, again, no parallel lines. No parallel lines. It's only AKA Blessing. I can see AKA Blessing has been here for the longest because he's listening to what I've been saying. You must write the lines that are parallel. If you don't write the lines that are parallel, look at that comment. Okay, please, guys, D plus D plus 80 degrees is equal to 180. Reason, co-int angles. Please, guys, indicate parallel lines. We don't have the letters to indicate the endpoints of the lines, so we say parallel lines. Then what do? D plus D, these are like terms. So you keep the variable, you add the coefficient. So it's like 2D plus 80, which is equal to what? 180 degrees. Then you solve, guys. You simply solve. 180 degrees, you take the 80 over minus 180. Then you get what? 2D is equal to 100. Then from there you divide by who? You divide by the coefficient of D. Okay? Alright? That's very important. And then you get D is equal to what? 100 divided by 2 gives us 50 degrees. So you guys are 100% those people that said D is equal to 50 degrees. Please, guys, you must indicate parallel lines, co-int angles, semicolon. You write parallel lines. Okay, if you guys don't get yourself in the habit in grade 8 and 9 of writing parallel lines, I'm telling you, if you are going to do maths in grade 10, this is going to come back to bite you. Maybe your teachers in the grades 8 and 9 level may be a little bit more relaxed with the reasons in not really penalizing you for writing parallel lines. But I'm telling you now, my grade 8s and 9s in my school, I tell them that you guys don't do this nonsense of not writing parallel lines. Because for this to hold, for the fact that the angles add up to 180 is simply because of those lines that are parallel. If the lines were not parallel, guys, the angles wouldn't add up to 180. Okay. F is saying, but don't you write that when you're doing congruency? Now that's another misconception. I don't know where you're taking that about writing parallel lines when you are doing congruency. Hey bo, hey bana. Hey, I don't know. I'm very lost with that one. Congruency in parallel lines. Remember, congruency has to do with the equality of shapes with their size and their angles. So I parallel lines. In twain. Hey, bana. All right, let's go to question 2, guys. Let's move on. Let's go on there. Question 2. Use the information in the sketch to find the values of x and y. All right. Okay. Use the information in the sketch to find the values of x and y. Show your workings and give reasons. All right. What's nice here, okay, is that you can see most how things are here. Okay. Ambro AMG, come down, my leader. We are going there. All right. You guys need to allow the concept to first settle in, the one about parallel lines. I need you guys to be sure about the parallel lines and the concept of parallel lines. All right. We're gonna go there. The questions are coming. Just hang on, hang tight, please. Right? So here it is, the diagram. We need X, we need Y. How are we going to find X, guys? Okay, Robin, may we co-interior first? Definitely, Robin. Definitely, Robin. It's wise to co-interior first because to do anything else is going to be a pain. So let's definitely co-interior first. It seems like Auntie Waffles. My goodness, we've got Auntie Waffles. Now this is something else. We've got an Auntie Waffles. Okay, so I guess Uncle has resigned and Auntie is taking over in mathematics, might I add. Don't mess around with Auntie Waffles there. Okay. Auntie Waffles is saying 2x plus 3x plus 20 is equal to 180. Do we agree, guys? Lekalakala, they said, is agreeing 100%. And I love you guys. Auntie Waffles and Lekalakala said, I would definitely, like, right now just give you a big, huge hug. You guys are amazing. You guys are phenomenal people, right? I love the fact that Lekalakala and Auntie are both indicating co-interior angles and they're writing the parallel lines. Okay, now that in this case we are given the actual letters, guys, so we don't have to just write parallel lines. Here we could just write, you know, the symbol for parallel lines, but here we can go ahead and identify what those parallel lines actually are. So we can say 3x plus 20 degrees. You see this 3x and this plus 20 and this x, this line and this line are what? Are parallel. Why do we say this line and this line are parallel? It's because the arrows are there, guys. Okay. So that means AB and what? And CD are what? Are parallel. So that means this is our U shape. Here is a U shape, guys. U. The armpits, right? And look at these angles. This angle is in terms of x. This angle is also in what? In terms of x. So when the person that actually said at the beginning, let me just check who it was. It was Robin. Robin says, may we co-interior first. That comment was very wise, all right? Because in these angles with their relationship, we have y as well. Now, someone else may have thought to themselves, why don't we just alternate first? Huh? Why don't we alternate first? Where does this guy see alternate? Remember, this line and that line are also parallel. So there is our Z shape. And you see that this angle and that angle form that Z shape. But the thing is, we don't have the value of x, we don't have the value of y. So we can't first alternate because we don't have x, we don't have y. And plus, x and y are different variables. But why don't we co-interior first? Yes, we can, because x and x are like terms. So we are bound to be able to solve for the value of x if we use this angle and that angle. So Robin was very wise when she said, can we co-interior first? I loved that comment. All right. I love the fact that Robin said, can we co-interior first? All right. So yes, we can. We co-interior first. We take 3x plus 20 degrees. We add 2x. These are our armpit angles. Why are they our armpit angles? There's the U shape, guys. This line is parallel, U shape. That line is parallel. So we say 3x plus 20 plus 2x is equal to 180 degrees. And then what do we write as our reason? We say co-int angles. Then we indicate, guys, AB is parallel to CD. You see, now we can actually be specific about the lines that are parallel because A and B indicate this parallel line. C and D indicate this parallel line. So when Robin said, can we co-interior first? Robin was very wise. She saw the like terms. And therefore, she saw that if there's a relationship between this angle and that angle, we can definitely use that relationship of co-interior angles, add these two angles together, equal to 180 degrees, and then we can solve for x. Now we can therefore solve for x. 3x plus 2x we know is 5x on the left. We take Mr. 20 over to the right hand side. We say 180 degrees minus 20 degrees. Then what do we get, guys? We get 160 with the 5x isolated. We then divide both sides by who, guys? By the coefficient of x, which is what? Which is 5. But what we do on the left, we do where? On the right. Then what's 5x divided by 5? It is x. Then what's 160 divided by 5? 160 divided by 5 is... You tell me, guys, what's 160 divided by 5? My beautiful, amazing people in the comment section. 160 divided by 5. It's 32. Thank you, thank you, thank you, people. Thank you, thank you, thank you. Thank you, thank you. Johnny Bravo. Thank you, guys. All right, so that means my value of x I now have. Now, since I have x, that means this angle is finally sorted. I can get the actual value of this angle. And as F indicated in the comment section, let's see, who is this F person? The actual name. Just want to read that name so that I don't... Okay, I'm just going to call you F. The 12th guy, because it's 12th guy 1. So, yes. Now that we have x, it means we can then look at the relationship between this angle and that angle. What is the relationship? Okay. The person who's asking, why are we adding this angle 2x and that angle 3x plus 20 and saying they are equal to 180? Remember, why? We are saying that because this is the U shape. What is the U shape? The relationship of the U shape gives us co-interior angles. What are co-interior angles? Those are angles that are found inside the what? The parallel lines. Inside this parallel line, inside that parallel line. The armpit angles where it stinks. And we said that the armpit angles where it stinks, just like with our armpits when they stink, we add roll on. What are we going to do to the angles? We add the angles together to give us 180. We add the angles together, they give us 180. That's why we say equal to 180 when we add these two armpit angles. They stink. Then we solve for x, we get x, all right? And we don't forget the parallel lines. AB is parallel to CD. We always include the parallel lines in our reason, guys. We include the parallel lines. So we got x, x is 32. Now what do we look at? We look at this angle and that angle. This angle and that angle. Why? Because we can see it is the Z-shape relationship. These two lines are also parallel. We can see the arrows, guys. So these two lines are also parallel. CA or AC is parallel to BD. So we look at these two angles, the 2x and the y. What are they? Alternate angle. What are they? Alternate angles. So what is the relationship? It is alternate. What do we know about the Z shape? The angles are equal if the lines are what? Are parallel. So what we simply do now is we say 2x is equal to y, and the reason we say that is alt angles. We state the lines that are parallel. AC is parallel to BD. I repeat, this angle is equal to that one. Y, Z shape, Z shape, N shape, Z shape. What is the relationship between 2x and y? Alternate. Since they are alternate angles, if the lines are parallel, we say 2x is equal to y. Z shape. We spoke about this earlier, guys. Z shape. This angle equal to that one. Z shape. This angle equal to that one. Z shape. This angle equal to that one. Z shape. Z shape. That's what we said. Alternate angles is the reason we state the lines that are parallel. 2x is equal to y. Alt angles AC is parallel to BD. But guys, we already calculated x. So that means in the place of this x, we are going to substitute in the place of that x the 32 degrees that we just found from the previous calculation. Then what is y then equal to? Therefore, y is equal to what's 2 times 32, guys? Come on, shouldn't be too difficult. Very good, F. It is 64 degrees. 64 what? Degrees, guys. It's 64 degrees. Now that wasn't too difficult. Wasn't that too painful? Okay. Yeah, degrees. There we go. There we go. I love it. Love it. Totally, absolutely love it. Absolutely. Why are we saying y is 64? Are you kidding me? Are you really asking why are we saying y is 64? Didn't I explain this too well, guys? Okay, didn't I explain this well? We first found x using co-interior angles. We took this angle, added that angle, say it equal to 180 degrees, we gave the reason. Okay. After giving the reason, we then solved for x. We got x is 32 degrees. Done. Then after that, we used the relationship between this angle and that angle because that gives us the Z-shape relationship. This angle is equal to that one, the Z-shape relationship. Alternate angles. So we said 2x is equal to y. Reason, alt angles, we state the lines that are parallel. And I said in the place of the x, which is 32, we substitute 32 degrees in the place of x. So that means 2 times. Guys, remember the 2 and the x have a relationship of what? Of multiply. When you substitute, okay, when you substitute using brackets. Brackets mean multiply as well. So 2 times 32 gives us 64 degrees. That's why we say y is equal to 64 degrees. This is just me concluding, okay, that y is 64 because 2 times 32 gives me what? 64 degrees. Okay. Moving swiftly along to the next question. All right. I believe now you guys have, you know, sort of like a feeling now of like how to approach questions that have to do with parallel lines, right? I hope so. Okay, look at this question. In the sketch, AD, we are told, is what? Is parallel to BC. Okay? Okay. Oh, thank you, sir. The thing is, I was moving when you were explaining that part, but thank you, sir. You are welcome, ain't Karover. Ain't you just Karover? Okay. Write down the value of x giving reason. In the sketch, AD is parallel to BC. You can see there. Write down the value of x, give a reason. So tell me, guys, very fast. Where was I yesterday? Where were you? Where were you? That's the $1 million question. I've been going live so many times. Where have you been? Okay. Let's start with x, guys. They say write down the value of x, give a reason. That's the first one. We are going to move on to number 2. But let's first answer 3.1.1. I see you guys are jumping to answer 3.1.2 because you see y very easily. What about x? What about x? Let's start with x, guys. Are you guys moving on too fast? You know, leaving your x behind. Come on, guys. Don't leave your x behind. What is this? No, I'm just kidding, guys. Okay, what's x? X is equal to? Thank you. X is equal to 75 degrees, though. Yes, yes, yes. X is equal to 75 degrees. Reason. Please, our reason must make sense as well. X is equal to 75 degrees. What would be the reason that would make beautiful sense? For me, what's the relationship I'm seeing? People are saying alternate angles, guys. You see, people are making me angry. Alternate angles. Why are you doing this? Why are you doing this, guys? You see, people are just writing alternate angles. No lines parallel, nothing. People are not specifying the lines that are parallel. Hey, bana, hey, bana, hey, bana. Thank you, Aliyah. Wow. No, Aliyah, you are also making me sad. You are identifying the wrong lines. AB is not parallel to CD. Hi, Aliyah. Aliyah, you must sing better. Aliyah, you must sing better. It's not these ones. It's not AB. Guys, AB is not parallel to DC. There's no lines that indicate parallel for AB. Guys, you are making me cry now. Thank you, Kino. Yes, Kino. Yes, Kino. Yes, thank you, Kino. Is it Kino, Both? Is it Kino? Is it Keno? Keno 3. Yes. Alt angles. AD is parallel to BC. How quick you guys are to forget. How quick you guys forget. AD is parallel to BC. AD is parallel to BC. So this angle is equal to this angle. Z shape. X is equal to 75. Please, guys. Please. Okay. Right. So that's why we say X is 75. Okay, we're done with that. Okay, and we gave a reason, and it's beautiful. Okay, write down the value of X. We can see 75 with X have a Z shape relationship. This is the Z. There it is. Look. AD, this and that. That's a Z, guys. All right. This angle is equal to that one. Z shape. So we say X is 75 degrees. What's the reason? Alt angles. Where are the lines that are parallel? AD is parallel to BC. Please, man. Okay. Next question. Write down the value of Y giving a reason. Josh, Y is 75. Okay. Josh is saying Y is 75. And Josh is saying vertically opposite. Y is 75. Do we agree? Do we see the Bagajuju, all of us? The Bagajuju angle. Bagajuju. Is it the Juju angle, guys? Is it the Bagajuju angle here? Okay. Yeah, definitely. Y is equal to 75 degrees. Y is equal to 75 degrees. Reason, vert, op, angles, equal. Thank you. Someone else could say something different. Someone else is allowed to say something different. Is there anything else that's different we could say? No, I'm just kidding, guys. There's nothing else you could say because we are not told whether these lines are parallel or not. Okay, let's be very careful with that. These lines here, we are not told that they are parallel. So we can't say corresponding. All right? We are not, there's no indication anywhere, and even the diagram itself doesn't tell us if whether this line and that line are parallel. Please, guys, do not make the mistake of thinking that. Okay, so the best course of action, the quickest way to get to the answer is simply to see the relationship between Y and 75. Y is equal to 75 degrees. Okay, yeah, that's it. There's no co-interior angles. There's no alternate angles where this is concerned. It's simply Y is equal to 75 degrees. Please, guys, not even co-interior anti-waffles, not going to help us here. Because remember, I do not have this angle, which will basically give me a specific which will relate to this. Okay, so be very careful. Tasha, I did say that the live will end at 12. Okay, I'm going up until 12 o'clock, but I did say that if people, have a hard time, please do make sure you depart hence. State whether AB, okay, state whether AB is parallel to DC and give a reason for your answer. Okay. Can we state whether AB is parallel to DC and they are saying give a reason for your answer? All right. Now, when you look at them, they are not. But I am going to tell you that those lines actually are parallel. Those lines are what? They are parallel. Now, some of you, I know you think I'm going crazy, right? I think that's what they said to. That's what they said to. That's what they said to Jesus when he walked on water, right? That's what they said when he called himself the Son of God. You know? Okay. Now, remember, we did find the value of x. Remember, we found the value of x? You guys still remember that? Okay, I'm just going to draw this roughly here. All right, just roughly. Okay, I hope you guys will bear with me here. I'm going to draw this roughly. This is very rough, guys. Ne? Please don't judge me. Don't judge me. Don't judge me. Please don't judge me. Okay, do we see? Okay, do you see this? Look at this. Look at this. Look at this beauty. Look at this beauty. Thank you, Josh, for the rose. You are so kind. My first rose for the night. Really appreciate Josh. Thank you so much, Josh. Right. This year we found it most that it's 75. Remember, I said to you guys, when you get an answer, thank you, Josh. You're so kind. You update your diagram. Update it. Make sure you update. You get an answer, you update. Okay, so this is 65 degrees. We found this, remember, because we did say x is 75 degrees. Reason, alt angles, AD is parallel to BC. There's the 75 degrees. Are we all together, ne? Okay, I hope we understand. Then we said we found the value of y. What did we say y is? Y is 75 degrees. What did we say is the reason? Vert op angles equal. So we update. Okay, now, guys, look at this line. Look at the angle you have there. Look at this line. Look at the angle you have there. What do you have? Let's turn over the diagram so that you can look at it very closely. What do you see? Okay. Okay. For this F shape, right? You see on top, the angles are actually both 75 degrees. So those are corresponding angles, but what do you notice about them, guys? They are equally. The corresponding angles are what? They are equally. So those people that have been hungry to use the reason corresponding angles equally, now is your time to shine. They said here, state whether AB is parallel to DC and give a reason for your answer. So what I'm going to say here is AB is parallel to what? To DC. Then I'm going to write my reason. Corresponding angles equally. That's when we use this reason. That is when we use the reason. All right? Okay. They are parallel because we are looking at corresponding angles in this diagram that are actually what? Equal. Top of this line, top of the other line on the same side of the transversal line. So that means if the corresponding angles are equal, then we can conclude that the two lines, this line and that line, are definitely parallel. That is why. So when we say, is AB parallel to DC? Yes, they are. Why? Because the corresponding angles are equal. Okay, yeah. So guys, the word itself, corresponding, has to do with the position of the angles. That's what corresponding angles have to do with. They have to do with the position of the angles. Okay, and that is very important. Corresponding angles has to do with the position of the angles. Okay, so the top on top means corresponding. The bottom means corresponding. So the minute you find that, Chini, those top angles, they are actually equal, then it's very important for us to then say, okay, since those corresponding angles are equal, it must then mean that the two lines, okay, which are AB and DC, are actually, in actual fact, parallel lines. This is the reason. Okay, I hope it makes sense. All right, that's the reason. Okay, guys, once again, Those who may be here and they're like, please do transformation. Like I said, I have videos that are already done. They are in my YouTube channel. The link is in my bio. I've done transformation. Okay, you can give yourself a chance and go and peruse through those videos and watch them. Okay, I've done transformation. I've done transformation type questions. Okay, very important. Then 3.1.4. What type of quadrilateral is ABC? D. Give a reason for your answer. What type of quadrilateral is ABCD? Give a reason for your answer. What type of quadrilateral, guys? You have these lines being parallel. You've just discovered these ones are also parallel. And you're also noticing that the opposite angles are equal. So what type of quadrilateral is that? Yes, Lerato, thank you so much. Thank you so much. Lerato, wena. Wena, Lerato. Wena, Lerato. Lerato. Yeah, your name says it all. Just full of love there. Yes, guys, parallelogram. Give a reason for your answer. Guys, we have both pairs of opposite sides. Both pairs of opposite sides are what? Are parallel. Okay, that's one of the reasons we could actually state and stipulate as to why we are saying that is a parallelogram. Okay, right? I can only speak of both pairs of opposite sides being parallel because, for instance, AD is parallel to BC, that I know for a fact. AB is parallel to DC. I also know that AD is parallel to BC. Okay, this I know. All right, it's just that I did not find out about if both opposite angles are equal, but this I know for a fact. The minute both pairs of opposite sides are parallel, we know that that is a parallelogram without any hesitation. Okay, without any hesitation. Now, wait a minute. Is there someone still crying about something? They're crying about 3.1.3. State whether AB is parallel to DC. Okay. Now is a good time to do the following with you. Let me ask you this question. Is CD parallel to EF? Is CD parallel to EF? Let me ask you that question. Is it? Thank you, Mr. Stop calling me. Thank you, Lerato. No, definitely not. Definitely not parallel. But wait a minute now. Listen, check this out. Okay. I also want to add a bit of a disclaimer here that the diagram is not necessarily drawn to scale. Say I did this to you. 150 degrees, 30 degrees. Now I want to ask again. Is CD parallel to EF? Is CD parallel to EF? Now. Okay, Josh is saying no. Lifetime saying no. Tasha is saying no. Mr. Stop calling me is saying no. M2K is saying no. Still Gubani is saying still no. I hear you, I hear you, I hear you. And M2K is the only one that's saying yes. M2K is saying yes. Now, M2K, because you said yes, I need you. I need you. I need you. M2K is saying yes. I need you. Now people are changing their tune as well. I can't, sorry. Okay. That's no problem. Guys, can I just ask you for a moment? What is this angle? It's 150, right? And what is this angle? It's 30, right? These two angles, all right? What position? Let's talk about the position of these angles. Aren't these angles in that position of U? Let's first establish that. Are these angles not in that position of U? Yes, they are. All right. They are found inside the parallel lines. But what do we notice about them? Okay. Okay. What do we notice about them? When you take those two angles together, guys, they add up to what? They are not equal, definitely not. But when you add them together, what do you get? 180. Okay? So, listen to me. I asked you guys, is CD parallel to EF? And I can say to you, CD is parallel to EF. Do you know why I say that? It's because, firstly, because of the position of these angles are what? They are co-interior angles. All right, that's the first thing. Why are we saying they are co-interior? Because they are in that U-shape position. They are found inside these lines. All right, so we call them co-interior. But what makes the lines parallel is because the co-interior angles are what? Are supplementary. So we use this reason, co-interior angles, sub, to prove that lines are parallel. The co-interior angles are supplementary. I use this SUPPL for short to mean supplementary. Co-interior angles supplementary. Some of you are using this reason, okay, when you are doing calculations, but you don't understand that this reason is used when you want to prove that lines are parallel. Okay, when you want to prove that lines are parallel, there are three ways to prove lines are parallel. There's this reason, co-interior angle supplementary. The minute you find angles that are in the co-interior position and you find out that when you add those two angles, doesn't matter how you see these lines, but the minute you find that those two angles add up to 180, it means that the lines that basically intersect this transversal are parallel. Why? Because you have found angles that are in the co-interior position that do what? That add up to 180. In other words, you found co-interior angles that are what? That are supplementary. So that then supports that CD is parallel to EF. This is one way of proving that lines are parallel. Finding co-interior angles that are supplementary. You say CD is parallel to EF. Why? Because I found what? Co-interior angles. Co-interior angles that are what? That are supplementary. These are the angles. 150 and 30 degrees. They are found in the co-interior position. When you add them together, you get 180. So that means CD is parallel to EF. Okay? Why? Co-interior angles are what? Are supplementary. Okay, guys, this is applicable to grade 8 and 9. But I tell you this, grade 11s, 10s, and 12 struggle with proving parallel lines themselves in the grade that they are in. Why? Because they did not get the basics clarified in grade 8 and 9. You are in a crucial grade 8s and 9s, because the basics of much of what is done in grade 10, 11, and 12 is done in this grade. But do you know what's funny? It's almost as if the devil, what he does, listen, it's almost as if what he does is he makes you guys play a lot in grade 8 and 9. That you don't really mind the important things that you do in your grade. And then what happens? You go to grade 10, 11, and 12, and you think you're going to do pure maths in grade 10, 11, and 12, right? You have the heart, you want to do it, you have the passion. But then what happens? You guys actually don't get to grasp the maths very well, because why? You don't have a solid foundation. From where? From grade 8 and 9. Then you cry in grade 10, 11, and 12. Then you quit maths and you go and do maths literacy. What nonsense, right? So if you guys would care more about the basics in this grade, you will kill maths in grade 10, 11, and 12. Distinctions won't be a problem, all right? Those people that you guys glorify and you laud and you want to bow down and you want to worship, and you see them get 100% and you see them get 100% in maths in grade 10, 11 and 12, and you're like, yo, that's so amazing. Like, if only I could do that. What nonsense. You could do it if you wanted to. You know? If you would be good at understanding your basics in grade 8 and 9, and if the basics were solid, then it would be easy. Yeah. So Pepe is saying, can you do geometry for grade 9? Are you kidding me? What have I been doing for the past few minutes? This is exactly the grade 9 geometry that I've been doing. What more do you want? Hey, high corner. All right. So guys, this is one way. Finding co-interior angles that are supplementary. That's how you prove that lines are parallel. This is one of the ways. I'm going to do the same thing. Look at this. I'm going to ask you again. A, B, and EF. Are these lines parallel? Now, hopefully you guys can answer the question the same way that you answered it before. Is A, B, and EF parallel, guys? Is A, B, and EF parallel? Very good. No, guys, A, B, and EF are not parallel. They are not. Okay? They are not. They are not. Okay? M2K, don't worry. That's why I've told these guys many times that I'll be doing early preparation classes for grade 10. The guys who are in grade 9, I'll be doing early preparation classes with you guys, but like I said, at a fee during the holidays. And I know some of you are going to be like, I want to sleep, holiday, maths during holidays. But I'm telling you now, if many of my learners that are in grade 10 this year have testified that those early preparation classes helped them a lot, and they are helping them to get better marks than most of their peers at school, then I'm guessing those preparation classes last year helped those learners that are actually doing well this year. So I'm saying that if you guys can do that with me, then you're going to see the power in that. Are these lines parallel? Well, no. There's no evidence here that we see of the lines being parallel. But look now. Listen. Check now. I want to ask you the same question after doing this. Now I ask again. Is AB parallel to EF? Is AB parallel to EF? Okay, look at M2K there in the comment section. Mr. Stop Calling Me is saying yes. Now I need a reason. All I need is a reason. What are you seeing that's making you say AB is parallel to EF? Because I agree with most people who are saying AB is parallel to EF. Now I can say, even me, I can also stand with you and say AB is definitely parallel to EF. What do you see that makes you say that AB is parallel to EF? Thank you. But you are missing that important last thing that you should say at the end of what you are saying. Okay, so most people are saying they are seeing alternate angles. Some people are saying corresponding angles, and I'm like sitting here and I'm like thinking, where's the F that you are looking at? Where is this F? Where are these F positioned angles that you are talking about? If you are saying corresponding, guys, where is the F? No, seriously, where is the F? Tell me. Where do you see this F? Bokamoso, thank you so much. It forms a Z. I really appreciate it. I swear, you can't be writing alt angles AB is parallel to EF. That's an irrelevant reason. It's not relevant. Remember, we want to prove whether AB is parallel to EF. Our statement is saying AB is parallel to EF. What's the reason? Okay, what is the reason? So you guys are right in saying you see Z. That's true. Does that make sense? You do see Z. Okay. Meaning, in other words, they are alt angles. But what about them, guys? What about these angles in that position? What about them? What do you see about them? This one is 30, this one is 30. So it means that those angles are what? Thank you, Lerato. Alt angles equal. That is when we use this reason as well. We only use this reason when we want to prove whether lines are parallel or not. Once we find alternate angles, angles that are in this position, angles that are in the Z-shaped position, we find out that those angles, we see two angles or identify those angles as being equal. They are there, they are equal. Then it means we can conclude and say AB is parallel to EF. What is the reason? It is because we see these alternate angles, which are what? They are equal to each other. So let's go back again. Remember at the beginning when I said is CD parallel to EF, and there was no 150, there was no 130, and you guys said no, the lines are not parallel, and I agreed with you. Then we then said put the 150, we put the 30 degrees, and then we asked, the two lines, are they parallel? And then you guys said no, 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 no. And then one person said yes. And then that one person, when I said, why are they saying yes? We could see that people didn't want to really say. Then eventually, we saw, key 150, key 30. These two angles are in which position? The co-interior position. Remember the word co-interior itself means this. Co is something that means together. It's a prefix that means together. Interior means inside. So these angles here, they are together inside these two lines. So the word co-interior refers to the position of the angles. Now, what are we saying about those co-interior angles? Those co-interior angles are actually what? When we add them together, they give us 180. When you have co-interior angles, guys, that add up to 180, it means that we can comfortably say that CD is parallel to EF. Why? Co-interior angles are supplementary. Okay. One way of proving that lines are parallel. Second way of proving that lines are parallel, identifying alternate angles that are what? That are equal. Does that make sense, guys? Then the last and third way, which is the way that we had used when we were proving number 3 in this particular question. In this particular question, remember we found, so I'm just going to come here actually. Remember the question was saying, state whether AB is parallel to DC and give a reason for your answer. You see, they're just saying state, that's all. And then they want a reason, that's all they want. So remember, 3.1.1, what did we do? We got X, okay? We got X, what was X? We got X as 75 degrees. And when we wrote our reason, we said alternate angles, and we stated the lines that are parallel. AD is parallel to BC. Go back to your book, you saw most. We update our diagram, we write 75 there. So this X now is 75. Are we together? Then number 2, the question says, write down the value of Y, give a reason. Remember, we said Y is equal to 75, and the reason was vert op angles. Then we update our diagram, we write 75. Now imagine, what do you have now in your diagram? You have 75 there, and you have 75 there. Does that make sense, guys? There's a 75 there, and there's a 75 there. And then the next question says, state whether AB is parallel to DC. You have 75 there, and you have 75 there. So my first question to you is, this 75 and this 75 are in which position as far as angles are concerned? Is this the co-interior position? Is this the alternate position? Or is it something else? If you're saying it's something else, please tell me what it is. What is the angle relationship? That is 75. It's in a certain position. This is also 75. It is in a certain position. What a relationship. Kanya, thank you so much. The angles 75 and 75 are in the corresponding position. So then, what can we say about the line AB and DC? Can we say the lines are parallel then, guys? If these two angles in the corresponding position are both 45, and why? Can we say AB is parallel to DC? Okay, I see K11 is saying yes, Narcissistic is saying yes, and Born One Motion is saying yes. Why, guys? What is the reason I can write in brackets? So we are all convinced now that AB is parallel to DC. What is the reason? Give me the reason, the foundation, the basis of why you are saying the lines are parallel. Give me that reason that will make me happy. Or that will make you happy, that will make you smile because you get the marks. Why? Why? Because the angles are equal. But if I write in brackets, I'm going to say corresponding angles. Corresponding angles. I'm waiting for that last word. Corresponding angles. Corresponding angles are equally. Okay? Thank you, Lerado. We can comfortably say AB is parallel to DC, and then in brackets, when we write our reason, corresponding angles equal. No, guys, not supplementary. Remember, corresponding angles, we never talk about supplementary when we're talking about corresponding angles, because remember, corresponding has to do with the F shape, top 75 degrees, top 75 degrees. So we found corresponding angles that are equal. So it's comfortable then for us to say AB is parallel to DC. Reason, corresponding angles equal. Right? So that is our third and final reason that we utilize whenever we identify parallel lines. So if I come to you and I say, is MN parallel to PS? Is MN parallel to PS? You look at that angle, you look at that angle. And if you look at that angle and that angle, you are seeing a relationship here of what? What is the relationship between the two angles? All right, we can see that MN is parallel to PS, but for what good reason can we say MN is parallel to PS? It is because corresponding angles, don't forget the equal sign. Corresponding angles equal. They are equal. These angles in this position, the corresponding angle position. So that is why we can say MN is parallel to PS, because corresponding angles are equal. Okay, guys, these are the three ways in which you can prove that lines are parallel. Either identify co-interior angles that are supplementary. You can see most the U shape. You are identifying co-interior angles that are supplementary. They add up to 180. Or you identify alternate angles, the Z shape, angles that are equal. Or you identify corresponding angles that are equal. All right? F shape, of course. Z, F, U. All right, please, guys, one of three ways. These are the ways to prove parallel lines. And I'll tell you this, these are the ways that even grade 10s, 11s, and 12 tend to struggle with, because they get even asked this question in their geometry type exams. Like you guys who are planning to do pure maths next year, you will be asked this question. And some of you, because you don't understand the basics in this grade, all right, if you fail to grasp it, you are going to not grasp it because you're failing to grasp it even now. Okay. All right. Hopefully that was an eye-opener for you. Bushle, hey, you want a break? Okay, let's take a 5-minute break. It seems like Bushle wants a break. That's not a break. I'm not a break person, you know. So Maybe I'll give you one. Let me give you one then. Let me leave you with this snack of a break. Let me leave you with this snack of a break. I think that's, as I said, guys. Let me leave you with this snack of a break. 5 minutes break. You're very welcome, Buko. I can see, Buko, you are really. Thank you. You're welcome. You're welcome, right? You're welcome. At the end of the day, I'm doing this for y'all, so oh, sorry, I think this is not as visible as I would have wanted it to be. Okay, so let me just do. But I think you guys can see the question. You can see, Mas. You guys can see this. Okay, just trying to give you guys a break so I can get one as well. Remember, guys, I said I'm gonna end this live at 12 o'clock. I know some of you need to go sleep and stuff. So please do go and sleep if you need to go and sleep. But I'll be ending this live at 12 o'clock because I just wanna push and see how far I can go, and then 12 o'clock I'll definitely be out of here. Live started at 9 today, probably will be the same tomorrow. But as well, maybe in the let's say afternoon at 12 tomorrow, 12 in the afternoon. I'll be posting this on YouTube, don't worry as well. So that's why I'm saying if you need to sleep, you can go. But I'll also most likely be going live tomorrow as well. 12:01, right? Because I can go live that time, 12 and 1. And then, like I said, if you miss anything, if I go live tomorrow for both, it'll both be grade 8 and 9, guys. Okay, between 12 and 12 to 3 tomorrow, 12 to 3. I'll be able to have a session from 12 to 3 tomorrow. During the day, 12 to 3. In the day, 12 to 3 tomorrow. And then I'll try to do one as well at night from 9 to 12. So tomorrow, 12 to 3 during the day, and then 9 to 12 at night. Okay, so tomorrow, 12 to 3, I'll be continuing on, guys, from where I've left off. Wherever I left off, I'll continue on from where I left off from today. Okay. Lerato needed tomorrow. Yes, 12 to 3 during the day. Just please let your other friends know. Let your friends know. Let people know that are in the same school grade, so they can come on here and they can have a time. But I'll definitely have a session tomorrow, 12 to 3. 12 to 3. 12 to 3. So check me out tomorrow, 12 to 3. Aiming 90%, very good. I'd not have you aim any lower. You aim high. I love that. 90, 95. When I teach, guys, I teach for 95 and above, to be honest. I don't teach so that people can just get mediocre marks. That's not the intention. The intention is for people to really excel. Thank you so much, Kaylan, and really appreciate the roses. I really appreciate it a lot. You have no idea. Thank you so much. Yeah, like I said, guys, I understand if you guys need to sleep, it's fine. Yeah, like I said, just spread the word about 12 to 3 tomorrow and stuff. Yeah, hopefully I'll be able to honor that. Yeah, okay. I guess tomorrow it will be from 12:30 to 3 a. 12:30. Not 12 exactly, 12:30. Cause yeah, 12:30 to 3. 12:30. 12:30 to 3, ne? Not 12 o'clock exactly, but 12:30 to 3. Alright. I'm glad you guys are at high percentages there. Alright, let's continue. I think I know yeah, hopefully that break was sufficient for people to kind of regroup, gather themselves again, so that we can kick off and just finish off strong. All right, let's finish off strong. Guys, calculate the values of the unknowns, give reasons. Okay, so we have x 101, we have 120. Now, this is a relationship between angles. You know, x 101, 120. That is very interesting. X 101, 120. 139. Okay, remember you what would be the reason? There's a very important reason we need to. Yes, Starlight, thank you so much. Angles around a point. Nice, I swear. Okay, I like that. Okay, I like that. Yes, right. Angles around a point. So yes, very good. From here to there is x, from here to there is 101, and then from here back to where we started is 120. So that is a complete, what we call revolution. Okay, it's a complete revolution. So yes, indeed, we would say x plus 101 degrees plus 120 degrees, and then we'd say it's equal to what? 360 degrees. Now, very famous is angles around a point. Okay, or you could say angles in rev. Now, rev is short for revolution. Okay, can you get in more detail for revolution and others? Tasha, I don't understand what you mean. Can you get in more detail for revolution and others? Yeah, so I don't understand when you say angles in rev. I mean, sorry, can you get in more details for revolution and others? What do you mean by that? Knobs are all tall. Knobs are all tall. Please do paper one. We're writing it tomorrow. I do not understand functions and relationships. I beg you. When I did GEC, I did functions and relationships. So You are also more than welcome, Tasha. What was this? Nobs or told to go to my YouTube channel. I did a live lesson on functions and relationships for grade 9. You can always go check that out if that is your struggle. I invite you to go and check that out. Actually, my link is in my bio. You can always check that out. If not, then I don't know if you're willing to wait for me to actually conclude the session at 12. I'm willing to explain that from 12 up until 12:30 for you, if you're willing to actually wait up for that long. But if not, then please, like I said, go check out my YouTube videos, because I'm ending only this segment of this section for paper 2 at 12 o'clock exactly. Right, so you don't know revolutions. So anyways, let me just explain that to you then, Tash. So here's the thing, Moss. If you have a protractor, your protractor moves from 0 degrees all the way to 180. All right, that's your protractor. Okay, hopefully you know what a protractor is. Hopefully you know what a protractor is. So please search for it, Nobs at all. Just search for it there. Yeah. So from 0 to 180, right? Then from 180 back to 0. 180 back to 0. That is a complete revolution. So that's like 0 to 90 here, right? That's why we say that is perpendicular, 90 degrees. From 90 to 180. From 180 all the way here to 270. And then from 270 back here to what? To 360. We call this revolving from 0 back to 0. We call that a complete revolution, right? So we say if angles sharing a common vertex around this point next to each other complete a full revolution, then we say those angles, they add up to 360 degrees. So this angle plus that angle plus that angle gives us 360, because look at this, like I said, from here, so we're starting here, right? And we are covering x. Then from x, we pick up this angle 101 from here all the way to there. Does that make sense? And then from here back to the x where we started is the 120 degrees. That completes a full circle or a full revolution, which basically angular wise we say is 360 degrees in total. So the angles adjacent next to each other sharing a common vertex around a point, we say those angles add up to 360 degrees. Okay, now someone like Tasha who asked, I don't understand the concept of revolution. Can you explain further? You need to confirm for me now in the comment section as to whether you understand it a little bit better or you still are lost. Okay, I'm gonna wait for you. You need to, answer me. Angles around a point. Okay, does angles around a point make a bit more sense? Are you sure, Tasha? And you're not just saying that because you're like, oh man, I'm scared of asking again because everybody else is probably like, can't just Tasha move on already. Tasha, if you don't understand, you must let me know, because you're not helping anyone by pretending as if you are fine with it, whereas you're not. So it's a good thing that you asked, and I'm glad that you're asking for clarity, all right? So like I said, you need to gauge as well that, okay, since these angles are next to each other, they share a common vertex. That there. These angles, do they complete 360 degrees? In other words, do they complete a full circle, right? Which is a bit different from angles that are adjacent next to each other, sharing a common vertex, but as they are next to each other, they don't complete a full circle, but rather they complete half a circle, a semicircle, which is like a protractor from 0 all the way to what? To 180. So that's why we say angles on a straight line, on the other hand, they don't add up to 360 or add up to any other angle, but they add up to what? 180 degrees. Okay, yeah. But angles around a point. Okay, angles around a point, they share a common vertex. This angle from here to there is x. From there to here, 101. From here back to where we started, that's a complete circle. Do you see that? So when we say angles around that specific point which share that, which is that common vertex, we say that those angles around that point add up to 360. That's our revolution. Okay, like I said, as opposed to angles on a straight line. Share common vertex next to each other, complete a straight line. Share common vertex around the point, complete a circle, 360 degrees. Okay, so that distinction is so important, so that when you do calculations, you actually do give the correct statement equal to 360, you give the correct reason. So like I said, any of these two reasons are acceptable. Angles around a point, or you can say angles in rev. This is short for revolution. Then you solve for x, here, my dear, beloved, amazing Tasha friend. You take that 120 over, you take that 101 over, and then what you do, you simply take your calculator, you punch it in, and then you get your value of x. 360 minus 120 minus 101. That gives you a beautiful answer. I think a lot of people commented earlier on and gave the answer that it is actually equal to 50. Was it 59? I thought I saw people say 59. I see 58 now from someone recently. Okay, 139. Okay, 139 degrees. So that is basically the angle x that was missing. So it's 139. Thank you so much, guys. I appreciate you actually taking the time to do the calculation. Statement, 1 mark. Reason, please guys don't forget the reason. And then your simplification, that's your 3rd mark. That's why 3 marks is dedicated. Statement, reason, answer. Statement, reason, answer. We are here now. 112. Straightforward, right? So I'm sure you guys can see the straightforwardness of answering these questions. Nothing much to it. Just nice, delightful, delicious meals that we are having here. Enjoying. So what's the relationship between y and 137? They share a common vertex. They lie on a straight line. They complete that straight line as they are next to each other, sharing a common vertex. So we say y plus 137 degrees is equal to what? 180. And ice bear, it's very icy where you are at. Ice with the bear, you just say angles on a STR line. And that's it. Angles on a straight line. Statement 100%. Reason, statement 100%. We solve. Very nice and easy. Very nice and beautiful, the solving. We get our y value. It's equal to what, guys? What is that y value? It is equal to, drum roll, the answer is hearts from balls, 43 degrees. Ladies and gents, all right, that was beautiful. 43 degrees. Damien Pala, the Pala commission. You can see Pala commission is helping there. Okay. You see this thing that's happening here. Hlongwane rocks up. I don't know where Hlongwane is. Is Hlongwane just joining in? And Hlongwane is like saying, please explain the first one. Okay, just spent literally a good 10 to 15 minutes explaining it to one person. Then Hlongwane comes up. I'm here now. And Hlongwane is like, please explain number 1. But I've spent a good amount of time explaining that question. All right. Hlongwane, what do you understand? Because you are saying I must explaining. What do you understand from this diagram? Let's ask you. Maybe you can comment there in the comment section. Yeah, Hlongwane. I think let me actually dare you to actually come up as well. What do you understand? Okay, so this is the pain of having people join in like literally midway in the session. All right. So yeah, Beauty by Ramsey. Hlongwane. 1, 2, 3 angles. From here to there, x degrees. From here to there, 101. From that point back to where we started with x, 120. We've just completed a full circle. We call that circle a revolution. Revolution angles add up to 360 degrees. Revolution angles add up to 360 degrees. So what we simply do is we say x plus 101 plus 120. We add all the angles we have there. We say equal to 360, like VAMP SL2MS is saying to you in the comment section. Then you write your reason, you say angles around a point, or you can say angles in a revolution. So angles around a point or angles in a revolution. Then from there you solve for x. Okay, very easy, very straightforward. Like Edwin is saying, you get 139 degrees is your value of x. Okay, do not forget the reasons, because when you do that, you are shooting yourself in the foot. It's like you are literally opening your chest, taking out your heart, throwing it outside, and basically saying, I'm going to try and survive without my heart. Well, good luck. Okay. Now we are here, 1.1.3. Okay, no, I am not better than your teacher, guys. I am not better than your teacher, please. I know you guys mean well by saying things like that, but I'm not better than your teacher. I'm just me, all right? I'm just me. Let's look at this one, guys. This is a straight line, okay? This is a straight line, all right? This is a common vertex. There are angles formed next to each other. Yes, it will be AM berries, as always. So what do we know about the relationship between x, 2x, and 80? Those people who are saying, can you teach me transformation? Go to my YouTube channel. I've taught transformation. All right. In actual fact, I think the second last live lesson that I uploaded on my YouTube channel, there was the paper that I uploaded as well here on TikTok, which just had the pictures, but the memo was not there. I did a live lesson for that question paper. It is the second last video that I uploaded onto my YouTube channel for grade 9 maths paper 2. So I obviously start that paper from the beginning right up until the end. And midway, I actually go through transformation and I explain transformation. So please go and check it out if you need that explanation. Tasha, what do you think I should actually add and teach tomorrow? I'm intending to continue from where I left off, okay? So just, yeah. Area and perimeter as well. If you go to my YouTube channel, the last video that I uploaded on my YouTube channel, I went specifically over area and perimeter. So you can go and watch that 3-hour, very long video that I did, but it was a live lesson like this, and I explained area and perimeter. I went into volume and surface area as well. I did triangular prism and the volume and surface area for triangular prism. I just did not do rectangular prism, cylinder, and cube. So yeah, you can go and check that out. But area and perimeter is explained, I think, very well with the circle, the square, rectangle, and all these other two-dimensional shapes. Go and check that out. That live lesson that I did yesterday, very long but very fruitful. I think if you can watch that, it will really, you will really gain a lot from it. Okay, gain a lot. So this one's straightforward, guys. X plus 2x plus 8 is equal to 180 degrees, as the Hlongwane you have identified there. Right? Don't forget the reason. Angles on a straight line. The link is in my bio, guys, for the YouTube channel. Link is in my bio. It's also called MATHSISAGAME. Go to the link. The link is in my bio. If you can't click on the link and send you directly to the YouTube channel, just copy the link, paste it onto your Google search engine, and then go search from there. It should lead you to the YouTube channel. Okay, go check out my playlists for grade 9 maths paper 2. Really a helping hand there. Okay, and grade 8 as well, I think. Yeah, combined. And just check at the headings and the headings of the video. It should guide you there as well. Simply put. Okay. So that one, x plus 2x plus 80 degrees is equal to 180. Okay, reason, angles on a straight line. Okay, so there we have a common vertex, which is beautiful. We have a common vertex, and these angles, they are adjacent or next to each other, and we can see from here to there, from there to there, from here to there, we complete that straight line. So that's a protractor sort of like shape, 180 degrees, angles on a straight line. Statement, our reason is on point, and then we simply do what? We solve for x. X plus 3, 2x gives us 3x. Remember, when we add like terms, guys, we keep the variable x, we add the coefficients. 1 plus 2 is 3, so it's 3x there. Then we take the 80 degrees, we transpose it on the other side. 180 degrees minus 80. We get 100 degrees on the left. Isn't that so? And then what we do then is we divide both sides by 3, and we get that amazing decimal fraction when we get the answer, right? Yeah, because we're not going to leave the answer as a fraction. We're going to leave it in decimal form. So what is that x value, guys, that we get there? I'll wait for you guys to tell me, and then I'll put it down when you guys are ready finally to tell me what the answer is. Thank you, Wanger. Rockstar Wanger. Okay, yeah. Yes, more specifically, because it usually says, Iceberg, can you please work on the usage of more refined, dignified language? You know, I don't really like that KU word that you started off with there. Understanding it in the vernacular is not so, it's not a very, I don't know, respectable term to use. Okay. There we have it, 1.1.4. We want x and we want z. Okay, so look at this. This entire angle is 143. This portion of the angle is 111. This portion here is x. And apparently this is y. And this here is z. Okay, we don't have this part of the angle. We have no idea what it is. All right, so that's very important to note, but maybe it is, we are able to find it. So if we look at y alone, is it possible to find the value of y on its own as it currently stands? Probably not. If we look at z alone, is it possible to find z alone at the moment? And I would dare say that, you see, this line is intersecting that one. And we can see the bagajuju, the X formation. It seems like this angle and that angle are definitely what we call them, what type of angles as well. Okay, it seems like Z can be found. Y is also a bagajuju angle with which angle? That one. And if we can find this specific angle, this part of the angle, that's also a bagajuju angle, and we can find the value of y. Katleho is indicating in the comment section 143 minus 111 would probably give us that angle, and you are 100% correct in saying that, Katleho. All right. So in my head, I'm thinking z can be found on its own. Okay. All right. And Wanga is telling us what z is equal to. Okay. Because in no particular order do we need to actually find what the angles are, as long as at the end of the day it makes sense. So our z value is 111, and the reason why we say that is because we can see the bagajuju nation. These are vertically opposite angle. This line intersects that one, and intersecting lines form vertically opposite angles, right? So indeed, z is equal to 111. Can we all understand that, guys? Here's the x, the bagajuju nation, all right? So therefore, Z is equal to 112. The reason why we say that is because these are vertically opposite angles. They are equal. So therefore, we can say Z is 112. Okay. Now, my dear beloved friend there, also, Ukatlejo, such a beauty. Such a beauty. This is still grade 8, guys. Okay. Y, look at this. The Y, the angle Y. It's vertically opposite to this angle. This angle here, we can find this angle. Because if you look at this entire angle, it's 143. You look at this portion of the angle, so we can take this big cake, cut off this slice, and get what is remaining. I'm saying it again. Take the big cake, 143 degrees. Take this small slice of the cake, which is 111, and you ask yourself, what is remaining to get 143? From 111, okay, to this angle, what is remaining to get 143? Okay, all right. I hope that makes sense. Okay, I hope that makes sense. Now, the person who's saying, can we label the remaining diagram? I don't want to mess up this book. So now you are like forcing me to redraw this diagram. Okay, because I don't want to mess up my beautiful. Does that make sense? I don't want to mess up my beautiful. 143, 111, Z, Y, X. Okay. Okay, does that make sense, guys? So I started off by saying Z is 111 degrees. And when I get these angles, I update my information. Z is 111. My reason for saying Z is 111 degrees lies in the fact that these are vertically opposite angles. Why? Because this line is intersecting that one. And thus it forms vertically opposite angles. Hence I updated 111. Okay. This line, all right, and that one make X a vertically opposite angle with that one. So I also know that's X. Okay, it's just that I don't know what the angle is yet. I'll find it, don't worry. This Y, this line, and that one, all right, basically form a vertically opposite angle for Y and that there. So I can find this angle. How? I'm saying this big angle 143 minus this smaller part of the angle, which is 111. I'm only asking myself, what is left for me to get 143 from 111? To get that, I can simply say Y is equal to 143 minus 111. That's where my vertically opposite angle actually is, because Y is equal to the total 143 minus 111. That will give me what Y is actually equal to. And I say the reason for saying that is vert of angles equal. So let's work that out. What's 143 minus 111? Snowy K. Snowy K. Snowy K, you're so nice. Snowy K was simply Pokey and Simone. Snowy K was simply Pokey and Simone. Okay, so Z is equal to 111. Y is equal to 32 degrees. Thank you, Simone. And then lastly, so let's update there. Y is not 37, Simone. Be careful. It's 32, okay? Be very careful, Simone. Okay, Y is 32. So I update that diagram. It's 32 there. Y is equal to 32. Then X. Guys, 143, the entire angle, and X are actually angles that lie on a straight line. This 143 and that angle, okay, this entire 143 plus this x are angles that lie on a straight line. Yeah, guys, that's why it's important for you to first understand the relationships of the angles in isolation. You see, when you understand the relationships in isolation, you know, first understand, okay, angles on a straight line. Angles share a common vertex. They complete a straight line, add up to 180. Oh, angles vertically opposite, Baga Juju Nation, E1 is equal to E2. B1, sorry, is equal to B2. Angle B1 is equal to B2. That's what we mean. Lines intersecting, vertically opposite angles equal. Once again, angles formed, angle B, 90 degrees. Angles, all right, sharing a common vertex, but the sum of which is 90 degrees. We call these angles individually next to each other, forming 90 degrees. We say they are complementary angles. They add up to 90 degrees, guys. Thank you, RSFTUT. I really appreciate tutorials combined. I'm guessing this is another faithful, amazing tutor in the platform who's doing the most for the kids and who's trying to really enhance and advance the mission of actually teaching and helping people with mathematics. GCSE at Excel higher. No, this is like high school mathematics, my dear friend Simone, but I'm guessing it's probably applicable to the program that you're talking about in your country. Simone, where are you from? Then, yeah, guys, please, using relationships between parallel lines, the F-shape relationship, the U-shape relationship, Z-shape relationship, and all of that beautiful stuff. Simone, you're from England. Wow, aren't I privileged right now? What an honor. All right, we're hailing all the way from South Africa. All right, and basically this is just yeah, this is mathematics as covered in the South African syllabus for kids this side. So I'm guessing it's probably relevant in that particular program you're speaking about. Good to have you. Good to have you, Simone. Beauty to have you. Okay, so here now, guys. Remember, I first said x, key x. Look at the x. Look at the vertically opposite angles. Z is equal to 111. Let's first start there. For my friend there who was saying, I don't understand at all what is happening. Look into the diagram. Identify the specific relationship that you see there. The Z and the 111, because this is the x vertically opposite angles. That's why we said Z is equal to 111 degrees. Okay? Okay? That's why we said Z is equal to 111. We updated. Then I could see this Y has another X, but this angle and that angle. You see, this angle and that angle. Here is the X. There, see this line and that line, those are intersecting lines. This angle is formed because of this intersecting line and that angle. So this is equal to that, but what is this angle? It is this entire 143 degrees minus this 111. It's like I'm given the full minus the part. The full angle minus part of the angle. This is part of this entire angle. A part of it is 111. The full complete angle is 143. So that's why we say 143 minus 111 so that we can get this other part of the full. Because remember, 143 is made up of this 111 and this part which I don't know, which is actually equal to y. So that's why I said y is equal to 143 minus 111, which gives me 32. And this 32 degrees is actually equal to the y. Does that make sense? So that's why we said y is equal to 143 minus 11, which gives us 32 degrees. Okay, yeah. Unfortunately, guys, if you are lost still, then it just means that I'm a very bad explainer of the maths, and you really need someone else to intervene. All right, and please, guys, make it a point that you get someone to intervene. For instance, if you see someone comment in the comment section, become friends. You see, for instance, Wanga is saying it makes sense. So if it makes sense to Wanga, maybe Wanga needs to connect with Richard, and then Richard and Wanga become friends, and Richard and Wanga help each other out, and then basically the mission of understanding is accomplished. Okay. Nah, but you're too nice with maths, really. Tanya is like, I understand the whole thing. I'm glad you do, Tanya. Like I said, so then the x now, we need the x. What relationship does x have with what we see? We see x, it's one of the angles that are lying on this straight line, guys. Okay, this is the thing. X is one of the angles that is lying on this straight line. Since it is, I can see this entire angle 143 is coming from this side of the line to there. You see, 143 is from here all the way to there. Okay, then X picks up from here down back to the straight line. What is this? It's a straight line. What is this? It's a common vertex. From here all the way to there, then from there to here. These are angles on a straight line. 143 plus x should be equal to what? 180 degrees, angles on a straight line. So it's simple. We just say x plus 143 degrees, okay, is equal to what? 180. And then we say, what's the reason? Angles on a STR or straight line. Then we solve for x, guys, and I think our England friend who was here earlier on, who may most probably be gone by now, actually did enlighten us there in the comment section and say that x is 37 degrees that long time ago. Okay, but now we actually are able to establish that through the sense of what is done, and then that's it. Pretty Boy Splash, I think you are done, but you see the thing is some schools in some other provinces are not done yet. So if you are done, hurrah, hooray, hooray for you, you are done. But other people, sadly, they are still busy. Some people are only finishing next week, Monday. Okay. Okay, let's check this one out. Which province am I in? Keep on asking, buddy. Keep on asking. Keep on asking. Surely the accent and the use of some of the language terms should have actually unpacked where I'm from. Okay, let's look at this one. Solve for x and y, give reasons. All right. Now, it's beautiful to always establish relationships between terms or expressions of the angles that have the same variable. So for instance, if you are going to look at 60 here, okay, you can see there's a line that's parallel, there's another line that is parallel. Okay, so there is an obvious relationship between, look at this y plus 40. You see? Z. So this guy and this guy have a relationship. Yes, there's an N there. I like that. ISXIE, you are correct. There's a relationship. Z or the N relationship if you want. That angle and that angle. What's beautiful is we can actually work with these two angles. Why? Because this angle is in terms of y, and this angle is also in terms of y. So in other words, the angles are in terms of a variable y, and the variable y is like terms. So we can actually work with these two angles because there's even a relationship we see between them. Okay, so you guys see alternate angles, and that's very important. But when you write your statement and your reason, please write your statement and your reason correctly. Then I want you to look at this angle. Look at this one and look at that one. What relationship do you see between these two angles? These are parallel lines. And what relationship is there between 2x minus 80 and 60? What's the relationship, guys? I'm waiting for a hero to save us all. Thank you, Bushla. Bushla. Is it Bushle or Bushle? Bushle R. Wanga. Yeah, very good, guys. You guys can see. You've got eyes to see. It's the F shape, guys. Look at this. F. Right? Bottom is equal to bottom. And because this angle is in terms of x and this one is a numerical value, we can definitely work with these two angles and equate them and solve. So there's no problem. What I need you guys to do is for you to become experts in being able to identify the relationships. Okay? It's pronounced Bushle. Oh, okay, nice. It's just that I saw Bushla. You see the R at the end. So that's why I pronounced it as such. So guys, here, Z, this angle is equal to that one. Alternate angles. You state the lines that are parallel. AB is parallel to EC. Please, you solve for Y. You get the Y value. That's all we want. Y. Then this angle, remember this is the parallel line. Bottom of this line. This is another parallel line. Bottom of the other line. These two angles at the bottom, we say they are bottom is equal to bottom. 60 is equal to 2x minus 80 degrees. Reason, corresponding angles. Then you state the lines that are parallel. AB is parallel to EC. You solve. Guys, please write the reasons correctly. AB is parallel to EC. Okay? When you state your reasons. Okay? Onye is saying is y 20 degrees. Do we agree, guys? Do you get y is 20 degrees? Because they say y plus 40 is equal to 3y minus 70 is equal to 3y. Y plus 40 is equal to 3y minus 70. Reason? Alternate angles. AB is parallel to EC. You solve. You get negative 2y is equal to negative 110. Okay, do the maths correctly then. Y plus 40 is equal to 3y minus 70. Reason, alt angles. AB is parallel to EC. Then y minus 3y is equal to negative 70 degrees minus 40. Right? Y minus 3y is negative 2y. Minus 70 minus 40, negative 110. Then what do? We divide both sides by negative 2, which gives us y is equal to, remember, negative divided by negative is positive, 2 divided by 2 is 1, we will get left with y. What's negative 110 divided by 2? That is equal to, thank you, 55 degrees. Let's not forget to state the lines that are parallel. Alt angles, AB is parallel to EC. So that is y. Then you see your mistake on here. Please, guys, some of you are going to lose marks because of algebra. Paper 1, solving equations. Okay? So that people can't come up with the right statement and the right reason. No problem. Okay? Some of you don't even write the reason correctly or don't write the reason at all. You lose marks. Please, guys, statement, reason. Statement, reason. Geometry requires statement, reason, you solve. All right? Yes, look, what I'm saying is that it's your solving the equation, paper 1, that is messing you up. Your algebra is not on point. This is paper 2. What I'm saying is that it's the algebra part, solving for an unknown, that is beating you senselessly. You see? Beating you to a pulp. And the other one is straightforward. 2x minus 80 degrees is equal to 60 degrees from this diagram, this one. 2x minus 8 is equal to 60 degrees. The relationship we can see there, the lines are parallel, bottom, bottom. What is bottom, bottom? That means corresponding angles. So those corresponding angles, remember, I write down the parallel lines. AB is parallel to EC. We solve for x. We solve for x. 2x is equal to 140. Okay, take the negative 80, becomes plus 80 on the other side. And then after that, knobs are tall, I'm coming back at you are funny, my goodness. Divide by 2 both sides, we get x is equal to 70 degrees. Knobs are tall is going to be the reason why I'm not going to be able to wake up tomorrow morning on time. I sense that is going to be happening, given that I'm actually still here. Okay, let's turn over our attention to something else, triangles related. Then I'm going to go to, so geometry of 2D figures. Let's see if you guys, how good you are here. Let's see here, 2.2.2. Solve for x. We've got a triangle, 57 degrees, 2x plus 10. We've got 4x plus 2, 27 degrees. We want to solve for x. How do we do it, guys? What do we do here? What relationship should we know about triangles? So I'm just going to recap a little bit so that people are in the know-how. First thing that I think is important is that we know that in a triangle, okay, angle A plus angle B plus angle ACB, this angle is equal to 180 degrees, guys. Isn't that so? Okay. Does that make sense? We know that the sum of angles in a triangle is 180. Okay, and we can write the reason as angle sum in triangle, sum of angles in a triangle, or we can say interior angles of a triangle. So in other words, the interior angles of a triangle add up to 180. Very important for us to know that. Furthermore, the exterior angle, you see this angle here, this guy outside, we call this Mr. External, Mr. Outside. Where do you teach? I want to come to that school. That's funny. Trust me, you wouldn't want to come to that school, because in as much as you guys are just crazy about the fact that I'm teaching you guys online and I'm not in your presence. Okay, I'll tell you now that the kids that I teach at my school are so sick and tired of me. It's the normal, ordinary thing that happens with every teacher. All students don't like their own teachers, but they will love other teachers who they are not in constant contact with. It's like your parents. I'm telling you. You know? It's like your parents. Anyways, let's just leave it there. No, I'm not better than your maths teacher, trust me. So like I said, angle A, I was saying this is an angle that we call the exterior. This word exterior means external, outside. The ordinary term is outside. So this is an outside angle. But most important is that this angle is an outside angle formed in a very special way. Yes, Mr. External, he's formed in a very special way. He's an angle formed aligned with the side of the triangle. Does that make sense? aligned BC. You see BC? You extend BC to become CD. Does that make sense, guys? Okay. Does that make sense? So BC extends all the way to D. So when you have an extension of a side in the same straight line, and this is the thing, guys, okay? When you have an extension of a side of a triangle in the same line and an exterior angle is formed, then we can say the following about that outside or exterior angle. Does that make sense? I repeat one more time. You see BC? He's in the same line as CD. CD must be in the same line as the side of the triangle. CD cannot be at an angle, you know. You can't just change direction. No. BC is in a certain direction, so CD must continue in that direction, being straight as BC. Okay? And then we call this, guys, what do we call this? We call this the exterior angle. It's an angle formed outside the triangle. Okay? With the special BC, which is the side of the triangle, extending to D in the same line. When that is the case, we say this is an exterior angle, and a relationship comes about. This exterior angle is actually equal to the sum. Now, guys, the word sum means addition. It is equal to the sum of the two interior opposite angles. This exterior angle is equal to the sum of these two interior opposite angles. Not these two, not these two, but these ones. All right. So here we are, guys. We say angle ACD. The middle letter indicates the angle. I repeat, angle ACD, or we can say, if we want, DCA. The middle letter with a cap to indicate the angle we are talking about. Angle ACD, the exterior angle, is going to be equal to plus the sum of what? The two interior opposite angles. So we can say angle A plus angle B is equal to angle ACD, this exterior angle. I repeat, angle A plus angle B is equal to angle ACD. So I think today, guys, I'm going to hold it right there. Okay, there's no problem with you guys wanting to close your eyes. Phoebe, if the letter D was not there, then usually they would be generous in the paper to ensure that they have maybe a number here, right there. All right, maybe they have C1, right? And that should be something that should be in the diagram. But in the event, guys, that they don't have a letter there, and you cannot name the angle using ACD or DCA, then just take those specific angles and work with them as they appear. So for instance, Phoebe, I'm just going to wrap up this lesson today, all right, with this. Do you see this angle? Do you guys see this angle? What do we call this angle? It's the exterior angle, right? Do you see these two angles? These are what we call the two interior opposite angles. So what relationship exists between this exterior and these two interior opposite angles. Okay, so I just explained the relationship. Okay, because that diagram sends us back to this one. The exterior angle, in other words, angle ACD, should be equal to the sum of these two interior, okay, the sum of the two interior opposite angles. Yes, starlight. Now starlight, just a little bit of an error there. The exterior angle is equal to the sum of the two interior opposite angles. So that is the reason, the exterior angle of a triangle. Okay, so I'm just gonna wrap up this session for today, because I think I don't want to completely butcher us. You know, I think some of us do need that shut eye, right? We are going to say 2x plus 10, 2x plus 10 plus this 57 degrees, this angle plus that angle. We are going to say those two angles, the sum of them is equal to this exterior angle. 2x plus 10 plus 57 is equal to 4x plus 27 degrees. What's the reason? Exterior angle of triangle. That is the reason. All right. So I repeat again. The exterior angle of a triangle is equal to the sum of these two interior opposite angles. Guys, it's these two angles. It can never be this one and that one. No, that's the sum that will be equal to that. No, no, no. It's not this one and this one. No, 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 no. It's always these two that are equal to that exterior. Okay? The sum of these two is equal to this exterior. So let's finish off and solve. 4x transpose. Take the 4x over to the left. Positive becomes negative. These are like terms. Does that make sense? Take the 27 is fine. Take the 57, transpose, becomes minus 57. Take the 10, it's positive, you transpose, becomes negative 10. What's 2x minus 4x? Remember, when we add like terms, we keep the variable, we subtract or add the coefficient. What's 2 minus 4? It is negative 2. Okay, then we come this side. 27 minus 57, that gives us a negative 30, and a negative 30 minus 10 gives us a negative 40 degrees. We then divide both sides by the coefficient of x, which is negative 2. And then we conclude the case. Negative divided by negative is positive, so therefore our answer, a negative divided by negative is positive. Then obviously the same is applicable this side. We get a positive 1x is equal to 20 degrees. So our value for x is 20 degrees. So guys, I'm going to hold it right there for tonight. Thank you so much for joining the live. I would hope that this session was helpful and you benefited. Okay? Yeah. I hope this section was beneficial and it was helpful. All right. So for those who are, like I said, for the live, I will go live again tomorrow, as I said, but at 12:30. All right, 12:30 during the day. 12:30 to 3. All right, 12:30 to 3, and I'm going to continue, guys. This is just going to be a continuation. I'm not going to start from the beginning. All right. Then maybe those who need some stuff in the morning, unfortunately, I have to be at work myself. At what time? I need to leave at 7 a.m. So those who are desperate for a morning live in the morning, okay, I will go live hopefully at 5:30 a.m. I know some of you are actually going to school at this time, or you're preparing to go to school. All right, so I just want to check. I can actually go live from 5:30 to maybe around about 6:45 a.m. and unfortunately I'm going to have to head to work at this time, so I can go live this time. Okay, so I can try and go live. That's if I wake up on time tomorrow. Well, actually it's already the next day. All right, it's already the next day right now, so I'll try and go live this time, so that I can maybe just take any questions that people may have about anything in the comment section, if like there's something pressing that people want me to focus on. But I have basically covered the majority or most of the things that you guys obviously need to know. Maybe here the things that may be additional will be things like quadrilaterals, Pythagoras. I know some Pythagoras type questions as well, and all of that other stuff. But for now, yeah, that's as much as I can actually give to you guys. Now, who is that young lady that had said? Was that a young lady or the girl that said, Nobza or all its time for functions and relationship? Yeah, I think I can do a bit of that for you. Our Koshlaza, thank you so much. You're welcome for the lectures, all of that stuff that you're asking. You guys are welcome. I'm happy to help. I'm happy to help and give a helping hand. So you guys are welcome very much. Tasha, thank you. Obsessed with the live together as we are again tomorrow, same place. Sure thing, Snowy K19. You're welcome, Tasha. Topics to be explained later on. Like I said, I'll be continuing on. So you guys just need to, if there are things that, if you were in the live like now, maybe when you jump off, okay, when you jump off, you can actually just let me know what other additional things you'd like me to cover in the live. I know people, paper 2 transformation geometry is there, surface area, but like I said, guys, there's live lessons that I've done. Area and perimeter I've done. You can look at my live lesson in my YouTube channel. The last live video lesson that I uploaded was on area and perimeter and the introduction to surface area and volume, but I only looked at the triangular prism, and I had physical objects to sort of like unpack and explain surface area and volume of a triangular prism. So there were physical things that I had on the live that I was showing, and I was actually showing you how you can identify surface area and how you can identify how the formula is formed and how it comes about from the diagram, from the object that I had. Okay, so hopefully you guys can check that out. I thought that was a pretty good lesson, and I know some people in the comment section were like, yo, this is really helpful. So check it out. Video quality, not the best. I know some people complain about the video quality of my videos, guys. I'm still at my genesis of this thing. As time goes by, don't worry. We'll definitely make things a little bit more quality when it comes to. But for now, the content, the teaching is quality. What I know is that the teaching is quality, the explanations are quality, but it's just that I know for some of you, you love aesthetics, you love presentation, you love order and all of that stuff. We'll get there, okay? Just be patient with me, we'll get there. Okay, so Utonzi, where is Nobza Otol? Nobza Otol, what do you want? You want help specifically with what? Okay, can I quickly end this live and restart the live, and then you can join or talk, because I feel like this video, I want to save it. I don't want it to be too long that it drags on to paper one content. So I'm going to end this live and restart again.